If anyone is joining, please help them with the page number or the topic name. I guess we'll have very less participants today. So, major nutrients, chapter 18, page number 180. If you have the textbook, page number 180, major nutrients. It's a small topic. We'll do a small topic today. So when it comes to food and nutrition are not the same. Food, what it means is if you have a vegetarian diet, plant and plant-based products, okay, vegan diet, plant and plant-based diet, vegetarian diet, plant as well as animal products, including dairy. And if you're a non-vegetarian, animal products, animals, plants as well. Okay, so this is what we call as food. But nutrition is the science of food. When we talk about nutrition, we are talking about the micronutrients, macronutrients, okay, at that level. So coming to the energy, different types of food, okay, energy building food, body building food, protective food. The food, food that is rich in macronutrients, carbohydrates, and fat are considered as energy yielding food. They provide you the fuel, the source of energy to do your activities and also the involuntary activities. Bodybuilding food is protein, protects you, makes a lot of hormones, helps in making enzymes, hormones, building blocks of the body. Okay, that is protein-based food. Protective food are rich in vitamins, minerals, antioxidants, and so on. And then we have fiber component as well. These are a type of carbohydrates, complex in nature, which will not be absorbed, but has many benefits to health. Water is also considered as a nutrient in this particular source of food. Water is also considered as a major nutrient. Okay. Coming to the energy part. Energy is not at all nutrient, but it is the byproduct of macronutrient metabolism. Okay, it is derived from macronutrients, specifically carbohydrates and fats. Proteins will also give you energy, but it is not the first priority. Proteins are not the first priority to give energy. So energy is derived from the breakage of hydrocarbon bonds. If you know the structure of any macronutrient, carbon chain is there, and along with the carbon chain, a lot of hydrogen atoms are also bound to it. When these hydrocarbon bonds are broken as a part of metabolism, as a part of any enzymatic activity, that's when you get energy. Okay, so you get energy when the hydrocarbon bonds are broken down in the carbohydrates, proteins, fats, etc. So carbohydrate is considered as a primary source of fuel. After that, fat, and the last option will be your proteins. Okay, and your brain consumes around 20% of the glucose that has been metabolized or derived from the food. Even though your brain has just 2% of the entire body weight, the contribution of brain towards the entire body weight is hardly 2%, but it consumes around 20% of the glucose that has been derived from food. So calories we calculate in kcal, kilocalorie. So 1 kilocalorie, we have took this in the nutrition science chapter as well, the definition of 1 kilocalorie. It is the temperature required to raise the temperature of 1 kg of water. Convert liter into kg, it's almost 1 liter. Okay, when you want to raise the temperature of 1 kilogram of water just by 1 degree Celsius, how much temperature is required? That is what we call as 1 kilocalories. For example, let's assume 1 kg of water is at 14 degrees Celsius. Now you want to increase the temperature of this 1 kg water by 15 degrees Celsius. Just 1 degree Celsius increase should be there. Okay. So you will require temperature, you require heat. Okay. You require heat to do this increase by 1 degree Celsius. So the amount of heat required to increase the temperature of 1 kg of water by 1 degree Celsius is what we call as 1 kilocalorie. Okay. The body needs energy for the following reasons. First is your basal metabolism. It means how your body is able to sustain life. Okay, cell function, replacement, synthesis, secretion, okay, of enzymes, hormones. These are not under your control at all. These all are involuntary actions that takes place because of your basal metabolism. Maintenance of body temperature, again, under it's not under your control. Non-stop working of cardiac cycles, like your heart is pumping, okay, heart is beating, you are breathing, your lungs are inhaling, exhaling, not under your control, it takes place involuntarily. Okay, brain function, okay, so these all requires energy, and this energy is coming from your basal metabolic rate. So basal metabolic rate refers to the amount of energy spent to maintain normal functions at rest. Even if you're not doing any activity, you're resting, you're sleeping, not moving, but still a lot of body functions are still being carried out. And that requires energy. Okay, and that energy comes from your basal metabolic rate. Then metabolic response to food. Energy is required for ingestion and digestion and absorption, transportation, interconversion, oxidation, and deposition of nutrients. Even to eat food, to chew food, to swallow food, energy is required. To digest food, energy is required. Just a moment, 1 minute. So, metabolic response to food, energy required for ingestion and digestion and absorption, transportation, interconversion, oxidation, and deposition of nutrients. This is the metabolic response to food. Even though you are eating food for energy, but to treat this food, to make this food convenient to produce more energy, you have to spend energy. Okay, to swallow, to chew, to digest, to make sure that the intestines are absorbing the nutrients. After absorption, the nutrients are being deposited wherever it has to go. All this are based on energy. Next, physical activity. Any types of physical activity is based on energy. Without any energy in the body, you will be lethargic, tired. No, you will not have enough energy to do any activity. So for every physical activity, energy is required. Growth. Energy is required for synthesizing the growing tissues and for sustaining the tissues themselves. Okay, growth hormone is not just important for the growth of a human body, okay, but also the growing tissues, to make growing tissues, for example, from the bone, from the skeletal system, okay, to make sure the growing tissues are present and these growing tissues are viable for the future growth. Energy is required to sustain them as well. In pregnancy, extra energy is required for the growth of fetus within the mother's womb, placenta as well. Okay, and all the other maternal tissues like uterus, breast, fat stores for their development. Okay, physiological development, energy is required. During lactation, energy is required for breast milk production and also for the energy that the breast milk has to give, lactose through lactose. Okay, the energy the breast milk has to give through lactose and fats to the infant. Okay, for that also energy is required. Assessment of energy. it's not it's a bit technical part, but we'll just go through it briefly. Okay, so oxygen and carbon dioxide output, through that you can assess how much energy is being consumed, or how like, for example, you feed you take an athlete, you put them on a calorimeter, direct calorimeter or indirect calorimeter. Okay, they are doing a certain activity, but you have closed their mouth and nose, and you have connected it to a device. So what this device is doing, it's extracting, it's making a tally of the oxygen and carbon dioxide output while the athlete is performing the activities. Okay, so based on the amount of carbon dioxide and oxygen that the athlete has given out, expired out, exhaled out, okay, through that you can assess how much energy was consumed during this activity. Okay. Next is you have the double labeled water technique. Here, the person has to be immersed in water. It's kind of an isotope dilution technique, where an oxygen labeled water is given to the individuals. Okay, and the urine samples are collected, and the rate of at which the oxygen isotope is found in the urine sample. Okay, that with that you can identify how much energy was being consumed. And then we have the whole body calorimeter, very similar in the way how I have explained the athletes. That is also an direct calorimeter method, whole body calorimeter. Okay, in which the athlete, it's a gold standard for measuring the basal metabolic rate. Yet the person is not doing any activity. Okay, in oxygen and carbon dioxide output, the person was doing an activity, and the oxygen carbon dioxide output was being tallied. In whole body calorimeter, usually to understand your basal metabolic rate, this is the best way. Okay, so in here the person will lie down on the device, and that device will check the heat generated in the body without any activity. What is the kind of heat generated in the body in kilojoules or kilocalories. So energy expenditure from the oxygen released and the carbon dioxide released over long period of time, even when you are at rest, that can be calculated through whole body calorimeter. Then we have extrapolating the food energy value, which means making sure that you understand the energy expenditure from the value of the food energy that was given. For example, 500 kilocalories breakfast was given. Okay, and how much energy the person has taken up from this 500 kilocalories to do their activity. Okay, the subtraction addition technique is used here in extrapolating the food energy. And then measuring the heart rate, again, when you do direct or indirect calorimeter technique. Direct or indirect calorimeter technique, in which the heart rate will be measured. Okay, how much heartbeats per minute is being taken up while you're doing a specific activity. Okay, based on that, this particular activity, if you conduct if you do it for 1 hour or 2 hour, we can get us not an estimate, but an approximate value of energy that you are burning. Okay, that can be found out. Then we have the carbohydrates. Examples of carbohydrates, your starches, sugars, milk, cereals, fruits, tubers. They're great sources of carbohydrates. Starch is a complex carbohydrate, and it has a lot of, it's long chain, it has a lot of glucose units. Lactose, another form of carbohydrate, it's milk sugar, only found in milk products. And then we have maltodextrin. It's a polymer. It is a laboratory made polymer obtained by enzymatic hydrolysis of cornstarch. Very sweet in nature. It's usually used for industrial purposes, packaged items and all. And then amylase resistant starch, it is present in food items like raw banana, um, green jackfruit, and other unripe food and vegetables. It has a more fiber activity. These are the carbohydrates. Carbohydrates give you around 50 to 60% of the total energy for the entire day. Usually comes from carbohydrates. And when you take Indian diets, 70% or more of the energy in an Indian diet usually comes from carbohydrates. Next, we have fiber. Fiber is an unabsorbable complex carbohydrate. It's a type of carbohydrate, but it cannot be absorbed. It cannot be broken down into glucose molecules, which can be used by the or absorbed by the intestine. Okay, different types of fiber: cellulose, hemicellulose, gums, pectins, lignins. Okay, these are different names of fiber. We have two types of fiber mainly: soluble fiber and insoluble fiber. Soluble fiber dissolves in water and it helps to reduce your sugar levels and blood sugar levels, glucose levels, and also it reduces the cholesterol levels. Okay, if you suffer from cholesterol or sugar issues, it's better to have more soluble fiber-based diet. Insoluble fiber does not dissolve in water at all, but they help in constipation, in alleviating the symptoms of constipation. So for adults, at least 25 to 40 gram per day of fiber is recommended. And for children, whatever is the child's age, plus 5 gram, whatever will be the answer, that is the fiber percent of fiber they should have on a daily basis. Protein, it's a very important component of tissue in the body and it helps in bodybuilding and tissue repair. Protein also leads to the formation of enzymes, hormones, and antibodies as well. Okay, so when your diet is deficient in energy, protein will be broken down. Protein is the last option. Okay, if the first option for your body is carbohydrates, then fats, and last option is protein, and it will be wasted. Once the protein is broken down from the body, it leads to muscle wasting. The thermic effect of protein is much higher than carbs, means your body requires a lot of energy to break down protein, to metabolize protein as compared to carbohydrates. Okay, so a lot of energy from your body is consumed for the digestion and absorption of protein as compared to carbohydrates. That's why thermic effect of protein is higher than carbohydrates. Protein leads to increase in the heat energy within your body. And there are 8 essential amino acids. Usually there are 24 amino acids. 8 of them are essential. The remaining are non-essential. Essential amino acids are the ones you cannot synthesize on your own within your body. You require them from diet. Omega-3 fatty acid and omega-6 fatty acid, omega-9 fatty acid, they all are part of essential amino acids. Sorry, not omega-3 or omega-6, that comes under fats. This is protein. So how do you check the best protein sources? PDCAA score and DIA score. PDCAA score is protein digestibility corrected amino acid score. DIA score is digested corrected amino acid score. Okay. Sorry, digestible indispensable amino acid score. That is the DIA score. Difference between both is that in both these situations, we have the idea of the nitrogen component present in the protein source before it goes inside the body. Now, after it comes out of the body, okay, in PDCAA, you check the nitrogen component in the feces. Food before you eat it and after you eat it, that after you digest the food, the amount of nitrogen that you found in your feces is what leads to the PDCAA score. But diascore is slightly different. The nitrogen component based in the food and the nitrogen component that you find in the ileum of the intestine, not the feces, in the ileum of the intestine. Okay, so that is a diascore. That is the main difference. Remaining everything is same, formula and everything is same. The only difference is in PDCA, you see the nitrogen component coming out of the body through feces. In diascore, you see the nitrogen component present in the ileum after digestion has been done. Okay, in the duodenum and jejunum, majority of the digestion is done in small intestine. In the ileum part, it is ready to enter the large intestine. So from the ileum part, whatever sample you can collect, that leads to the estimate of protein digestibility. Okay. So the diascore has a much better approach in identifying which is the best source of protein. So based on the PDCA score, two tables are given to identify the best source of protein. One is figure 18.1 and next is table 18.1. You can refer these two to identify the best source of protein. Next, we have fats. Fats are concentrates of energy. 1 minute. So fats are concentrates of energy. They are very rich in energy. 1 gram of fat can provide 9 kilocalories of energy, and they also provide essential fatty acids. And essential fatty acids are basically polyunsaturated fatty acids, and they are called the queen of vitamins. And sometimes it is called as vitamin F as well. Okay, so linoleic acid and linolenic acid are the two main essential fatty acids. Alpha linoleic acid as well. It must be present in certain ratios. You can refer that. So among polyunsaturated fatty acids, omega-6 to omega-3, it is in 5:1 ratio, is the most desirable ratio. Okay, higher omega-6 and low omega-3 content is found naturally in groundnut, sunflower, safflower oils, vegetable oils, and seed oils in general. Okay, they can reduce the free radical activity within your body, angiotoxicity. If you have weak immunity, if you have a reduced glucose intolerance or risk for diabetes. Okay, for all these categories, polyunsaturated fatty acids in form of omega-6 and omega-3, higher omega-6 ratio, lower omega-3 ratio. Okay, it is beneficial. Then if you categorize fat, you have two main categories: visible fats and invisible fats. Invisible fats are the fats you cannot see with your naked eye, but they are present, like in deep fried food, processed food. You know fat is present, it's not visible. So invisible fat is the oil, butter, ghee, whatever you use in cooking. It is visible. You have more control over how much quantity you have to pour. Okay, so that is visible fat. In invisible fat, you do not know. The content of fat is not right there in front of you. You can definitely check the ingredients list, but it is not right there. The visible fat means the content is right there in front of you. You can hold it, you can pour it, you can have a control over how much fat to use. Invisible fat. In invisible fat, it's not the case. Then we have MCT, medium chain triglycerides. Coconut oil has this medium chain triglycerides, good for cardiac health. Okay, usually coconut oil is a uh, it's a saturated fatty acid. Okay, not good for heart health, but since it has good MCT, medium chain triglyceride, that makes coconut oil a better option as well. Then monounsaturated fatty acid, MOFA. So approximately 10% of your energy on a daily basis should come from monounsaturated fatty acid, 10% should come from polyunsaturated fatty acid, and 10% should come from saturated fatty acids. Okay. So saturated fatty acids are found in animal fat, coconut oil, palm oil. Monounsaturated fatty acid is found in peanut oils, olive oil, sesame oil, canola oils. Omega-3 fatty acid, that is found in sunflower oil. Um, Omega-6 polyunsaturated fatty acid, specific kind of it, is found in fish oils, walnuts, flax seeds, soybean, canola oils, etc. Okay. Cholesterol, cholesterol you will get only from animal product. You have endogenous cholesterol and exogenous cholesterol. Endogenous means the cholesterol you already have within your body. Okay, human body has cholesterol. Exogenous is the cholesterol that you get from food, from animal products. Okay, dairy, even dairy products have cholesterol in it. Any animal product will have cholesterol in it. Plant products do not have cholesterol. So cholesterol, there are two types, low density and high density. Low density is bad for health. It can get accumulated in small blood vessels and get accumulated over a period of time and lead to varicose vein, DVT, etc. But high density cholesterol or high density lipids keep moving. They keep moving in the blood circulation. They cannot stop at one place. They are kept moving. Okay, because of which they usually do not form cardiac blockages. Then we have trans fat. Trans fat is very bad in nature. Hydrogenated oils, animal fat. Okay, and these are usually solid fat at room temperature, and as soon as you heat them up, they melt it down. Okay, uh, largely found in um, bakery items, processed food, over processed food, junk food. Okay, consumption of trans fat is very risky. Specifically, if you have a family history of coronary heart diseases, it can increase your cholesterol levels. So avoid having trans fat. They do not have any nutritional component. Zero nutrition, high calories. This is what trans fat is. So you have to avoid it. Ratios they have given, just read it on your own. The different ratios, not that important. Water is also considered as a nutrient. It because of the amount required on a daily basis. It takes care of all the biochemical reactions in the body. It fills up the interstitial, intercellular parts of the body as well. Water is also required for digestion, absorption, transportation, dissolving nutrients, elimination of water products. So based on all these activities that water do within the body, it can also be considered as a nutrient. So that's about today's session. If you have any queries, you can mention in the chat box. There are not much participants